damped oscillations. Damped oscillations ante enna? The oscillations whose energy continuously changes with respect to time. Okay na?
Yes, sir.
Like for example, if this is a simple pendulum, okay, I have given certain force for this one, so it has gone to the maximum position ikkada. From mean to extreme varaku poi, malla it will come to somewhere here right now. Mean position nunchi extreme position varaku potunda, malla extreme nunchi return mean ki vastundi. Malla mean nunchi extreme ki potundi on the other side. Malla extreme nunchi mean ki vastundi. Ana kada? మరి కొంచెంసేపు అయిన తర్వాత కొంచెం పైకి పోతుంది, మళ్ళీ కిందికి, మళ్ళీ కొంచెం కింది, పైన పైన కొంచెం, ఫైనల్లీ ఏమైపోతుంది, ఆగిపోతుంది. అవునా కదా? సో ఈ ఆగిపోవడానికి రీజన్ ఏంది? సరౌండింగ్ ఎనర్జీస్ దాన్ని ఫోర్స్ ని ఆపోజిట్ చేస్తున్నాయి. ఎయిర్ ఫ్రిక్షన్ అవన్నీ యాక్ట్ అవ్వడం వల్ల ఏమైపోతుంది రైట్ నౌ ఇట్ ఈస్ రిడ్యూసింగ్ ఇట్స్ ఎనర్జీ కంటిన్యూస్లీ విత్ రెస్పెక్ట్ టు టైం. సచ్ టైప్ ఆఫ్ ఆసిలేషన్స్ ఆర్ కాల్డ్ యాజ్ వాట్? డాంప్డ్ ఆసిలేషన్స్. ఓకేనా?
Yes, sir.
Like say for example, one more example if I take you right now for you. Like say for example, there is a spring, and to this spring there is a block which has been connected, and a block is being immersed in the water anukunna. Like say for example, it is immersed in the water like this. Okay.
Yes, sir.
Now see, when I give the jerk for this one, will it make an assertion better about this one? To and fro motion move avutunda leda? Because of the buoyant forces. Yeah, because of the buoyant forces, what is happening? After a certain time, this body again will come back and stop it basically.
Yes, sir.
Now see, what are the forces will be acting on this one? In the damping forces, F resultant force will be equal to minus some opposing spring force, that is nothing but minus of K into X, minus some opposing force, some B constant into your velocity V. Okay. What is B here, beta? B is your some damping constant. B is your some damping constant. See, this Kx is already because of the spring. And this water is also exerting that force. No? So that force may be water, that may be air, anything else. So that is the reason I have taken some constant K into velocity V. So this will be the basic equation for your restoring force. So restoring force is equals to minus of K into X minus of B into V, where B is known as what, beta? Damping force. Clear?
Yes, sir.
Sure. Now if I simplify this one, beta, force can be written as mass into your acceleration is equals to minus of your K into your X minus B into V. Can I write like this?
Yes, sir.
Now can I write the acceleration in terms of your X, beta? Because
yes, sir.
Velocity is your
Yes,
dx by your dt, and acceleration is your right now for me dx square divided by, that is d square x by your dt square. అంతే కదా?
Yes, sir.
ఎందుకని యాక్చువల్గా ఏమవుతుంది acceleration అంటే acceleration is dv divided by dt. So that is equals to d by your dt. Velocity అంటే already ఇది వచ్చింది కాబట్టి this one is dx divided by your dt. So d into d and d square into x by your dt square. That is the reason acceleration can be written as like this. Can I write like that?
Yes, sir.
So this will be equal to your m into acceleration is d square into your x divided by your dt square is equals to minus of your k into your x minus of your b into v. That means I can write this one as of your d square into your x divided by your dt square, isn't it, is equals to, if I'm taking this minus term inside, this will become for me plus k into your x divided by this mass will become right now for me here down. Antena?
Yes, sir.
This minus also if I take inside, this will become for me b by your m into velocity can be written as of your dx divided by your dt. This will be equal to 0. So this is your damping equation. Clear, Buddha?
Yes, sir.
So d square x divided by your dt square. So this is a total equation which you need to remember. Now if I solve this equation and simplify beta, we'll be getting one standard equation. So solution of this equation will be equal to solution of this equation. We'll be writing in one simple term. X is equals to your some constant A into your cos of your omega t plus of your phi. The derivation of this one is beyond our syllabus better. Don't bother about the derivation. So the solution of this equation, what I am writing is X is equals to A into cos omega t plus of your phi, where A is equals to, this is very important for our exam. A is equals to your some constant A naught exponential to the power of minus B by your 2m into your t. Yeah.
Yes, sir.
This is the equation which you need to remember. A is equals to your A naught exponential to the power of your minus of B by 2m. An actual solution of this equation is X is equals to your A into cos of your omega t plus of your phi. Clear, beta? So this one you need to remember for solving the numericals. Done?
Yes, sir.
Any doubt?
No, sir.
Sure. In this one, beta, this omega value also will be writing. This omega will be equal to your under root of your k by your m minus b by your 2 into your m whole square. Angular frequency formula in terms of mass and damping constant that will be equal to how much? Omega is equals to under root of k by m minus b by 2m into your whole square. Okay, or else this can also be written as omega is equals to under root of your omega is equals to k by m can be written as of your omega naught square minus of your b by your 2 into your m ka whole square. Okay.
Yes, sir.
Very important formula beta. Angular frequency formula. This is a formula which you need to remember. Omega is equals to your under root of your k by m. Under root of k by m is represented by what beta? Omega naught square. It is represented by omega naught square. K by m completely is represented by omega naught square. So this is the standard equation which you should remember for doing the numericals. These three formulas are pakka you need to remember at any cost. Try to budify it or try to learn it by heart so that you can directly use it for your JEE mains exams. Okay, now?
Yes, sir.
So what is the equation we are representing to remember here right now? A is equals to your A naught into your A is equals to your A naught exponential to the power of minus B by 2m into t, and omega value is under root of your k by m minus b by 2m whole square or under root of your omega naught square minus of your b by 2m. Okay, na?
Yes, sir.
Sure. Here 2-3 points good to call now. See, first one. If b by 2m b by 2m, if it is lesser than omega naught, then such type of condition is called as of your under damped oscillations. Okay, na? In the same way,
Yes.
if b by 2m is equal to omega naught, that condition is called as of your critically damped. Is called as of your critically damped. If b by 2m is greater than omega naught anukundaam, that is called as of your over damped condition. What are the conditions for your under damped, critical damped, and as well as of your over damped? These points you need to remember and tell them. So this will be the condition if b by 2m is lesser than omega naught, or if b by 2m is equals to omega naught, or b by 2m is greater than omega naught, then that is called as of what for me? Under damped oscillations, critically damped oscillations, and over damped oscillations.
Yes, sir.
Okay, na?
Yes, sir.
Sure. And next one more important point you need to remember: mechanical energy. That means energy of your damped oscillations. Mechanical energy means what beta? Sum of potential energy and kinetic energy.
Yes, sir. Total
So that
energy.
energy, yeah, that will be equal to your E is equals to your half into m into your omega square a square kada total energy. So E is equals to your half into m into your omega square. A value already we know. So what is that A value? This will become for me A naught exponential to the power of minus of B by entonana
2m.
B by your 2m into your T whole square.
Yes.
That means I
Yes,
can
sir.
write this one as of your E is equals to your half into m into your omega square. This will become for me your A naught square, and this will become for me exponential to the power of minus B by m into your T. అంతే కదా ఇది వెళ్ళిపోతుంది.
Yes, sir. Yes, sir.
That means this is totally a constant కదా. ఇది చూడు హాఫ్ ఎం ఒమేగా స్క్వేర్ ఏ నాట్ స్క్వేర్ అంటే మనం ఈ లాగా రాసుకోవచ్చా? దట్ మీన్స్ ఈ విల్ బికమ్ ఫర్ మీ హౌ మచ్ ఫర్ మీ ఈ నాట్ అని పెట్టుకోవచ్చా బికాస్ ఇక్కడ ఏ నాట్ ఉంది కాబట్టి. So this will be exponential to the power of minus of B by your m into your T. So this will be the energy formula. E is equals to your E naught exponential to the power of minus of B by m into your T.
Yes, sir.
So this is the important formula you need to remember again. Clear?
Yes, sir.
Sure. Let me give you one example. See whether we can solve it or not. J means la adigina question anna. See here. The amplitude of a damped oscillator becomes 1/3 in 2 seconds. Okay. If its amplitude after 6 seconds is 1 by n times the original amplitude. 1 by n times the original amplitude. Try to read the question carefully, beta. The value of n is dash. First option is 3 square. Second option is cube root of your 2. Third option is 3 power 3. And fourth option is right now for me 3 power 4. Something like this. Cube root of your root 3. Yes, sir.
Yes, sir. Try this.
The amplitude of damped oscillation is chad. And A value. A
Yes,
value is
sir.
how much for me? 1/3 of its maximum value. A naught.
Yes, sir.
What is our formula? A is equals to A naught exponential to the power of minus B by 2m into your T. A value pictured A naught divided by 3, that is equals to your A naught exponential to the power of minus of B by 2m into T. After what time? 2 seconds. This one is 2 seconds.
Yes, sir.
In this one, this A naught will get cancelled. Okay.
Yes, sir.
So that means I can write this one as of your 1/3 is equals to exponential to the power of minus of B by 2m into your 2. అంతే కదా?
Yes, sir. Sir,
So,
2 cut type.
So I can transfer this 2 beta here right now.
Yes, sir.
So this will become for me 1/3 to the power of 1/2 will be equal to exponential to the power of minus of B by 2m and raskocha. The total constant value in the manaku.
Yes, sir.
But problem the amplitude of a damped oscillator becomes 1/3 in 2 seconds. If its amplitude after 6 seconds is 1 by n, and 1/6 seconds cheyala.
Yes, sir.
Isn't it? So for 1/6 seconds, and again same formula, A is equals to your A naught exponential to the power of minus of B by 2m into your T. T is equals to how much time beta? 6 seconds.
Yes, sir.
So now A value is equal to how much for me right now in the problem is telling? 1 by n
అంటే
times the original value కదా.
డివైడ్ చేయాలి
Hmm.
బై n.
So this value can be written as a is equals to a naught. This total value is how much beta? Exponential to the power of minus of b by 2m value ante 1 by 3 kada. This will
Yes,
become
sir.
for me 1 by 3 to the power of your 1
1
by
by
2
2.
into your 6
Yes, sir.
into your 6. Ante 2 ones are 2 threes are. Ante a value will become for me how much? A naught divided by enta
27.
3 power 3 ante 27. అన్నా కదా ఏ వాల్యూ ఎంత
Yes,
ఇచ్చాడు
sir.
మనకు ఏ నాట్ డివైడెడ్ బై ఎన్ ఇస్ ఈక్వల్స్ టు ఏ నాట్ బై 27. ఏ నాట్ విల్ గెట్ క్యాన్సర్. సో ఎన్ వాల్యూ ఇస్ ఈక్వల్స్ హౌ మచ్ ఫర్ మీ 27.
3 cube.
అంటే ఎంత వస్తుంది ఆన్సర్
3 raised to 3.
3
Cube.
క్యూబ్ థర్డ్ ఆప్షన్.
Yes, sir.
వాట్ ఎన్ ఐడియా.
Yes, sir.
చలో ఇంకో క్వశ్చన్ చూపిస్తాను. Like if I directly tell you amplitude becomes 1 by 2 of maximum 1 by 2 of maximum అంటే a naught after 4 seconds. After 4 seconds. The question is find amplitude after 12 seconds. After 12 seconds. Can you try it? Same question.
Yes, sir.
Same formula in manaku a is equals to a naught exponential to the power of minus of b by 2m into your t. అంతేనా.
Yes, sir.
ఈ వాల్యూ ఎంత అవుతుంది హాఫ్ ఆఫ్ ది మాక్సిమం అంటే ఏ నాట్ బై 2 ఇస్ ఈక్వల్స్
Yes,
టు యువర్
sir.
ఏ నాట్ ఎక్స్పోనెన్షియల్ మైనస్ ఆఫ్ బి బై 2m టు ది పవర్ ఆఫ్ యువర్ టీ వాల్యూ ఎంత ఆఫ్టర్ హౌ మచ్ టైమ్ 4 seconds. అవునా.
Yes, sir.
So this a naught will get cancelled. So this will become for me 1 by 2 to the power of your 1 by 4. ఈ పవర్ ని ట్రాన్స్ఫర్ చేస్తున్నాను. దట్ ఈస్ ఎక్స్పోనెన్షియల్ టు ద పవర్ ఆఫ్ మైనస్ ఆఫ్ బి బై యువర్ 2m. అవునా.
Yes, sir.
Now find the amplitude after how much time 12 seconds kada.
Yes,
అంటే
sir.
a is equals to your a naught exponential to the power of minus b by 2m into this will be after how much
12.
time 12 seconds. And this will become for me your a naught into this total value is how much for me 1 by
Half
2
raised to
power
1 by
of your
4.
1 by 4 అంతేనా
Yes,
into your
sir.
12.
Yes, sir.
అంటే ఎంత అవుతుంది a naught divided by 2 power 3
8.
అంటే this is a naught by your 8. This will be your answer.
Yes, sir.
Yeah.
Yes, sir.
So I hope you got an idea how to do the problems related to this one.
Yes, sir.
Any doubt in this one?
No, sir.
Okay.
Yes, sir.
sound wave equation గుర్తుంది కదా నాన్న?
Sorry, sir.
Yesterday sounds equation గుర్తుంది కదా?
అవును సార్.
See this question better. The equation of your transverse wave traveling on a rope is given by y is equals to 10 into sine pi. This will be 0.01 into x minus 2.00 into t. Okay, where y and x are in centimeters and t in seconds. So the maximum transverse speed of particle in rope is, options are 63 centimeters per second, 75 centimeters per second, 100 centimeters per second, and 121 centimeter per second. First read the question carefully. What is telling? The equation of a transverse wave. The given equation is y is equals to how much? 10 into your sine. You take this pi inside. This will become for me how much beta? Pi 0.01 months matta ventana 100 kada? Divided
Yes,
by 100
sir.
into x minus this pi you take inside. This will become for me 2 pi into your t. Now compare with the standard equation beta.
Yes, sir.
Compare with y is equals to a into sine kx minus omega into t.
Yes, sir.
Ante k value is how much for me? Pi by 100 and omega value is how much for me? 2 pi. Chudu. This is completely
Yes,
2t. In this k is equals to this much.
Yes, yes, yes.
And Vp max adugutunnadu. Velocity of the particle which is maximum. Vmax formula is how much for me? A into your omega.
Yes, sir.
Amplitude is given how much in the problem you see? If I see the problem in this one, A is equals to your how much for me? 10. That means this one is your 10 into omega value is how much better? 2 pi. Isn't it? So that will be equal to how much for me? 20 pi centimeter per second. Or that is your 20 into 3.14 centimeter per second. So 20 into 3.14 and 10,000. 63 approximately. 63 centimeters per second. And there 2 3 is 6.
Yes, sir.
So what is the answer for this one? First option.
First option.
Clear?
Yes, sir.
Sure. Question
సార్ దీంట్లో పై వాల్యూ 3.14 తీసుకోవాలా లేకపోతే యాంగిల్ ది పై తీసుకోవాలా ఎట్లా తెలుసు?
పై వాల్యూ జనరల్ గా పై వాల్యూ అనేది ఇవ్వకొచ్చి బికాజ్ ది యూనిట్స్ ఆర్ ఇన్ సెంటీమీటర్స్ దట్ డిపెండ్స్ అపాన్ ఆప్షన్స్.
ఓకే
యాంగిల్స్ లో గనక సైన్ లో గనక ఇచ్చింటే యూ షుడ్ హావ్ బీన్ టేకెన్ 180. జనరల్ టర్మ్ కాబట్టి 3.14 తీసుకుంటాం.
ఓకే సార్.
నెక్స్ట్ వన్. సింపుల్ harmonic progressive wave is represented by the equation y is equals to 8 into your sine 2 pi 0.1 into x minus of your 2t. Okay, beta? At
Yes, sir.
any instant, the phase difference between two particles separated by your 2 centimeters in the x direction is Options given are 18 degree, 36 degree, 54 degree, and 72 degree. Sure. Again, same. Compare with the standard equation. What is the standard equation, beta? If I'm just writing the given equation, y is equals to 8 into your sine 2 pi local తీసుకెళ్ళిపో. So if I'm taking the 2 pi inside right now, because this is 2 pi out on the other, దీని లోపల తీసుకెళ్ళిపోతే ఎంత అవుతుందన్న 2 pi into your x divided by 0.1 అంటే divided by 10 కదా.
Yes, sir.
Minus 2 into 2 4 pi into your t. అవునా?
Yes, sir.
Now compare it with y is equals to a into sine.
Sine
This will
2x
be
minus
k
omega
into
t.
x minus this will
Omega
be equal
t.
to your omega into t. అవునా కదా? అంటే k వాల్యూ ఎంత ఉంది మన దగ్గర 2 pi by 10. ఒమేగా వాల్యూ ఎంత ఉంది 4 pi. ఏ వాల్యూ ఎంత ఉంది 8. వాడు అడిగింది ఏంది ప్రాబ్లంలో at any instant the phase difference between the two particles separated by 2 centimeters in the x direction is. That means if I'm writing the phase difference formula in the delta phi is equals to k into delta x. Okay na?
Yes, sir.
So now let me try to simplify this one. So a value is given for me, k value is given, omega value is also given. K value enta na, k is equals to how much for me 2 pi by 10. 2 pi by 10 ante enta pi by 5 antena 2 ones are 2 5s are.
Yes, sir.
So this will be equal to your pi divided by 5 into delta x. Delta x will be equal to how much? ఎంత చూడు ప్రాబ్లం లో delta x.
Sir, question no.
చూడు
2 centimeters.
2 centimeters separated by distance of 2 centimeters అంటే into 2. So what is the answer right now? 2 pi by your 5. So that will be equal to 2 into, now pi value ఎంత తీసుకుంటాం మనం ఇక్కడ 180 divided by 5. ఎందుకంటే ఆప్షన్స్ దేంట్లో ఇచ్చాడు మనకు రేడియన్స్ లో ఇచ్చాడు 18 degree, 36 degree,
Yes,
54 degree, 72 degree. So that is the reason 2 into 180 divided by 5. Clear? So that will be equal to
Yes,
how much?
sir.
5 ones, 5 is a 15, is 6. That means 2 into your 36. That will be equal to 72.
Yes, sir.
So got an idea? 72 will be the answer. Clear?
Yes, sir.
Any doubt in this one?
No, sir.
Next question. Density of first string is equals to 2 times the density of second string. Okay, and the radius of first string is equals to 4 times the radius of second string. Then v1 by v2 is how much in the string? This is a given diagram. Here there is a string and here there is a block attached to this one beta. This is 12 kg. And here there is one more thing. This one is 4 kg. This is the first string and this is your second string. Shall try yourself. Density of the first string is given for me. That means rho 1. Density of rho 1 is equals to 2 times of rho 2.
Yes,
And
sir.
radius of the first wire is equals to 4 times of radius of R2. velocity formula beta, v is equals to under root of your t by your how much mu. నేను చెప్పాను
Yes,
velocity
sir.
in a string.
Okay.
So that is equals to under root of your t divided by mu is equals to mass per unit length. That is equals to under root of your t into your L. Mass is equals to volume into density. That is equals to under root of your t into your L. Mass is equal, the volume is equals to your how much? Mass into length into density. This length will get cancelled. So what is the formula I will be getting? V is equals to under root of your t. Mass will be equal to how much beta? Mass will be equal to your volume is equals to what? Area into length. Sorry, mass is the question. Volume is equals to area into length. This length gets cancelled. So it is A into your rho. This is your formula. V is equals to under root of your t divided by A into rho. Clear? Now area, how do you write beta? Area will be equal to pi into your r square in terms of radius. That means I can write V1 is equals to under root of your tension in the first string T1 divided by this will be equal to rho1 into pi into your r1 square. Adhe vidhanga V2 velocity in the second string is V2 is equals to your T2 divided by rho2 into pi into your r2 square. Can write like this? Which in the formula?
Yes, sir.
So V1 by V2 what do you do? So V1 by your V2 is equals to. So what I'll be writing right now here? T1 divided by your T2. So this pi will also will get cancelled. So this will be into rho2 divided by rho1 into r2 square divided by r1 square. ఇట్లా వస్తుందా ఫార్ములా?
Yes, sir.
చూడు ఇది ఫస్ట్ స్ట్రింగ్ కాబట్టి దీంట్లో టెన్షన్ ఎంత అవుతుందన్న? సో దీంట్లో టెన్షన్ వచ్చేసి T1. ఓకే, దీంట్లో టెన్షన్ వచ్చేసి T2. The weight of the body is 4g down. అంటే T2 will be equal to how much beta? 4 into g. T1 will be equal to how much beta? చెప్తావా సారి? This will be equal to 12 into g plus of your T2. అంటే 12g plus 4g. That will be equal to how much? 16g. అర్థమైంది ఎట్లా రాశాను? చూడు,
Yes, sir.
ఇది 12 kg బాక్ పైన ఒక టెన్షన్ T1 అప్వర్డ్ ఉంటుంది. దీని వెయిట్ 12g యాక్టింగ్ ఇన్ ద డౌన్వర్డ్. ఈ టెన్షన్ కూడా ఉంటుంది కాబట్టి T2 ఇన్ ద డౌన్వర్డ్ డైరెక్షన్. సో T1 is equals to 12g plus T2. For 4 kg block, so 4 kg block paina, only one tension is acting, that is T2, and weight of the body is 4g. That is the reason T2 is equals to 4g. So
Yes, sir.
16 into g value is 10, that will be equal to your 160. This will be 4 into 10, that will be equal to your 40.
Yes, sir.
Okay, na? So now I can substitute that values. V1 divided by V2 is equals to under root of this will be T1 ఎంత వచ్చింది 160, T2 ఎంత వచ్చింది 40 into rho2 value is rho2, rho1 value is how much? 2 times of rho2, that is given in the problem, into R2 is R2 square, R1 is equals to how much for me? 4 times of your R1, that means 4 4 is 16, 16 times of your R2 square. అంతే కదా? అంతేనా?
Yes, yes, sir.
చూడు ఇక్కడ వచ్చే డాటాలో ఆల్రెడీ rho1 is 2 times of rho2 and r1 is 4 times of r2. r1 square కాబట్టి 16 times of r2 square. ఈ r2 square rho2 this 0 will get cancelled. 4 1s are 4 4s are 16. So this will be equal to how much for me beta? 4 1s are again 4 4s are 16. So this will be equal to how much? V1 by your V2 is equals to 1 by root of your 8. అంతేనా?
Yes, sir.
4 1s are 4 4s are 4 2s are 8. అంతే కదా?
Yes, sir.
1 by root 8 అంటే ఎట్లా రాయొచ్చు?
1 by 2 root 3.
So V1 by V2 is equals to how much for me? 1 by 2 root 2 is your answer. Got an idea
Yes,
how to
sir.
do such type of a problem?
Yes, sir.
Velocity in your strings. Clear?
Yes, sir.
Sure. Next one is speed of sound. Speed of sound. Okay. longitudinal in nature. Longitudinal nature ante enna, the particles are moving in the direction of your wave. Antena?
Yes, sir.
Transversal aithe particles are moving perpendicular. Now if I'm talking about the speed of the sound in the solid beta, speed of the sound in the solid is calculated with the formula v is equals to under root of your y divided by rho. What is y here? Y is your Young's modulus.
Yes, sir.
Y is your Young's modulus and rho is your density of your solid. Density of your solid. The same way, second one. In liquid or gases. In liquid or in your gases. In liquid or in gases, velocity of your sound will be equal to under root of your b divided by rho, where b is nothing but what beta? Bulk modulus.
Yes, sir.
B is your bulk modulus. Again, rho is your what? Density of your gas, or it can be a liquid, depending upon the given data. Okay.
Yes, sir.
So these are the standard formulas you need to remember. No need of the derivations for the examinations. Directly you can remember. For solids, the velocity of the sound is calculated with the formula under root of y by rho. For liquid or gases, velocity of sound is equals to under root of your b by rho, where b is bulk modulus and rho is the density of the gas or liquid. Clear?
Yes, sir.
Next one. Newton's formula. See, according to the Newton, he said that the propagation of the sound waves is isothermal in nature. Done, beta?
Yes, sir.
According to Newton, sound propagates isothermally in medium. Isothermally means what, beta? Temperature will remain constant.
Delta T equal to 0.
Now, our temperature will remain constant. So for isothermal bulk modulus, very important formula, beta. This also comes in the elasticity chapter. Isothermal bulk modulus is represented by B. B is equals to minus of change in pressure divided by change in volume by original volume. That means this can be written as of minus of your dP. This V will go up, so it is V divided by your dV. Okay.
Yes, sir.
That is very important formula. Try to remember it. As it is an isothermal process, PV is equals to constant. From Boyle's law, I can write PV is equals to your constant. From ideal gas equation, PV is equals to nRT. N is a constant, R is a constant, temperature is a constant, so PV will be equal to your constant. Now if I'm differentiating this one, D in the place of your this one PV divided by your dV must be equal to how much? 0. So if I differentiate it, dP by your dV into your V plus of your dV by V ante 1, this will be your into P will be equal to 0. Ante kada?
Yes, sir.
So minus of V into your dP by your dV will be equal to your how much, beta? Will be equal to your pressure P. That means I can say that isothermal bulk modulus, this total one, isothermal bulk modulus is equals to how much for me? Pressure P. Antena?
Yes, sir.
So I can say that B isothermal will be equal to your pressure. The total term ni nenu isothermal ani anukuntunna. Very important bit. Okay.
Yes, sir.
Tell me what will be the inverse of bulk modulus, beta? Gurtunda? Inverse of bulk modulus. Inverse of your bulk modulus is what? Compressibility.
Yes, sir.
Is called as of your compressibility, represented by letter K. So K of your isothermal will be equal to 1 by B of your isothermal. That will be equal to 1 by P. Very important formula again.
Yes, sir.
So if I am drawing a graph between isothermal bulk modulus and pressure, it will be a straight line crossing from the origin. If I am drawing a graph between K isothermal and pressure, it will be inversely proportional. But a rectangular hyperbola. Okay, na?
Yes, sir.
Now tell me what will be the velocity of sound in the Newton's formula. So velocity of your sound will be equal to under root of your B isothermal divided by rho. Antena? B isothermal is equal to how much? Pressure. That means velocity
Yes,
of
sir.
your sound is equals to under root of your P by rho.
Yes,
How do you
sir.
write the value of P? We know PV is equals to N into R into T.
Yes,
So
sir.
P is equals to what I can write N R T divided by V. So if I'm taking number of moles is equals to 1, then velocity of sound will be equal to under root of P is equals to how much for me? RT divided by, so this will be equal to how much beta? V. Or
Yes,
else I
sir.
can write number of moles in terms of mass beta.
Yes, sir.
ఒకవేళ మాస్ లో రాసుకోవాలనుకోవడం, how do you write this one?
Given mass upon molar mass.
Yeah, N is equals to how much for me? Mass by volume kada. N is equals to your mass by your volume, isn't it?
Sir, n అంటే number of moles కదా.
So this is molecular mass divided by volume. అంటే
So
1 n
volume ఎట్లా వస్తుంది అక్కడ?
mass is equals to molecular weight nana. So number of moles is equals to, how do you write it?
Given mass
N
upon
is
molar
equals
mass.
to mass given divided by molar mass.
Molar, yes, sir.
So P is equals to your N is equals to M into RT divided by your M into
MV.
your,
Yes, sir.
isn't it? So mass by volume can be written as
Pressure. Sorry, sorry. Density,
density is
density.
equals to mass by volume. So
Density.
mass by volume is density కాబట్టి P is equals to rho into RT divided by M.
Yes,
That
sir.
means this will become for me rho into RT divided by M into rho. This row will get cancelled.
Yes, sir.
So velocity of sound will be equal to under root of your RT divided by molecular weight. So this will be the isothermal bulk Newton's formula for the velocity of sound. Okay.
Yes, sir.
But experimentally it was found to be wrong. Experimentally it was found wrong. Then his student only called Laplace restudied this one and he has given a correction for this one, and he told that the sound is traveling in the medium not isothermally but adiabatic in nature. Okay, so next one is your Laplace correction. Laplace correction. He corrected his teacher and he told that the Newton's assumption that the speed of the sound in the medium is isothermal is wrong. So he told that propagation of sound wave is adiabatic in nature. Okay, adiabatic in nature. Adiabatic in nature, and now how do you write the velocity of sound? So velocity of sound is equals to under root of your B adiabatic but not isothermal divided by rho. So this was the statement given by the Laplace. Only small correction he did it. Okay.
Yes, sir.
Now if I'm talking about your adiabatic bulk modulus, how do you calculate this value? Isothermal bulk modulus ఎంత వచ్చిందన్న చూడు, isothermal bulk modulus ఎంత వచ్చింది? This is isothermal bulk modulus.
dPV by dV.
సో దాన్ని మొత్తం సింప్లిఫై చేస్తే ఎంత వచ్చింది? B isothermal is equals to pressure వచ్చింది.
Pressure.
అవునా కదా? Let us try to see what I'll be getting here. Adiabatic bulk modulus లో ఫార్ములా ఏంది మనకు? Bulk modulus is equals to minus of delta P divided by delta V divided by V, or else that is equals to minus of your dP into your V divided by your dV. రాయొచ్చు ఎట్లా?
Yes, sir.
Adiabatic process అంటే ఏంటి? PV to the power of gamma is equals to constant కదా?
Yes, sir.
Isn't it? So now differentiate it right now. Minus of your dP into V divided by your dV will be equal to your gamma times of your pressure. And I can say that B adiabatic is equals to how much beta? Gamma times of your pressure.
Yes, sir.
దీన్ని differentiate చేసుకోవాలి with respect to V. Okay?
Yes, sir.
Derivation మొత్తం మీకు అవసరం లేదు. Just remember that isothermal bulk modulus is equals to how much for me? Gamma times of your pressure.
Yes, sir.
And adiabatic value is how much beta? So adiabatic is gamma times isothermal is how much? Pressure.
Yes, sir.
Isothermal bulk modulus is equals to your pressure. Adiabatic bulk modulus is equals to how much for me? Gamma times of
Gamma
your
pressure.
Okay.
Yes,
Now how do you
sir.
write the value of gamma beta? Gamma is equals to your Cp by Cv. Molar specific heat at a constant pressure divided by
Yes,
molar
sir.
specific heat at your constant volume.
Yes,
For
sir.
monoatomic gas, gamma for your monoatomic gas will be equal to 5 by 3. That is 1.6.
Yes, sir.
Gamma for your diatomic gas will be equal to 7 by 5. That value is 1.4. And gamma for your triatomic gas will be equal to your 9 by 7. That will be equal to 1 by 1.29.
Yes, sir.
Okay, now very important things you need to remember this one.
Yes, sir.
Sure. Next one. Compressibility చెప్పండి.
K.
Compressibility is your K. That means K is equals to how much for me? 1 by adiabatic bulk modulus. That means this will become for me how much? 1 by gamma times of pressure. అవునా కదా?
Yes, sir.
No doubt.
No, sir.
So that means I can say that K into your pressure P will be equal to how much for me? 1 by gamma.
Yes, sir.
K is your what? Compressibility. P is your what? Pressure.
Pressure.
Isn't it? That is equal to how much for me? 1 by gamma. That means if I'm drawing a graph for compressibility K versus your pressure, so we'll be getting the graph rectangular hyperbolas. Ante kada?
Yes, sir.
This will be for monoatomic, this will be for diatomic, and this will be equal to triatomic.
Triatomic.
So I can say that velocity of sound will be equal to how much? Velocity of your sound will be equal to, what is the formula? Under root of your B adiabatic divided by rho kada?
Yes,
So that
sir.
is equals to under root of B adiabatic is how much? Gamma times of pressure divided by rho. That means that will be equal to under root of gamma into R into T divided by capital M. So velocity of your sound is equals to how much beta? Actually, gamma into R into T divided by capital M. So this is the formula we need to standardly remember for exam.
Yes, sir.
Any doubt?
No, sir.
The formulas అన్ని you should remember it better. For examination, directly formula based questions అడుగుతుంటాడు వాడు.
Yes, sir.
Okay. K into P is equals to 1 by gamma, or K is equals to 1 by gamma times of your pressure. Monatomic diatomic relation in the, even if I draw a graph for this one better, what will be the graph? Can you tell me? If I'm drawing the graph for your B adiabatic and pressure. Drawing the graph between adiabatic bulk modulus versus pressure. It will be a straight line.
Straight line. Yes,
Gamma
sir.
times 3, monatomic, diatomic, and triatomic. It lost some.
Yes, sir.
This will be mono, this will be your di, and this will be your tri.
Yes, sir.
Okay, na? Okay, adugute. Clear, beta?
Yes, sir.
Next one. Dependence on temperature. Sound ela depend outundi temperature pine. So what is our formula for this sound beta? V is equals to under root of gamma into R into T divided by capital M kada?
Yes, sir.
That means V is directly proportional to root of T. T is what? Absolute temperature. So V square is directly proportional to your T. That means as temperature increases, velocity of sound is also increasing, isn't it? So what will be the graph for this one better? V versus your T will be your parabolic. Antena? V square directly proportional to T
sir.
kada. Avuna kada. That means this will become for me how much? V square is equals to K into T. So graph of V versus your T is what? A parabolic. Antena? Sure.
Yes, sir.
Pressure. Pressure पर not depend out. This is the dependence on your temperature. Temperature is represented by letter capital T. Now pressure formula beta V is equals to under root of your gamma into P divided by rho. Or that is equals to under root of gamma into RT divided by capital F. That means P by rho will be equal to how much beta? P by rho will be equal to RT divided by capital M. Isn't
Yes,
it?
sir. Yes, sir.
If I keep the temperature constant, RT by M is equals to constant on then P by rho is equals to constant.
Yes, sir.
So if T is equals to constant, ఎందుకంటే T ఒకటే వేరియబుల్ ఇక్కడ R ఎట్లో constant, M is also constant. If T is
Yes,
also
sir.
constant, total term will be constant.
Yes, sir.
That means P by rho is equals to your constant, isn't it?
Yes, sir.
So if P by rho is constant, that means pressure and density will also change better.
Yes,
That means
sir.
if pressure changes, density also changes,
Yes, sir.
isn't it? Because P by rho is equals to constant కాబట్టి directly proportional. That means there is no effect of the change in pressure at a constant temperature and the speed of this pump. Antena?
Yes, sir.
There is no effect of change in pressure. No effect in pressure. At what beta? At your constant temperature on speed of sound. Clear?
Yes, sir.
So P by rho is equals to constant. Very important term beta. So there is no effect of your change in pressure at your constant temperature on the speed of your sound. That means if the pressure is changing, density is also changing. Clear?
Yes, sir.
Sure. This is a small question. At what temperature the speed of sound will be double the speed at 27 degrees centigrade? At what temperature the speed of sound will be double the speed at your 27 degrees centigrade? Options given are 54 degrees centigrade, 108 degrees centigrade, 927 degrees centigrade, and 27 degrees centigrade. How do you represent the velocity of sound with temperature beta? V is directly proportional to root T kada?
Yes, sir.
So I can write V is directly proportional to initial temperature and the room temperature ante 27 plus 273 ante kada? T1
Yes, sir.
is equals to 27 plus of your 273 and this will be equal to how much? 300 Kelvin.
Yes, sir.
Isn't it? The same way, when velocity is doubled, then the temperature will be some changing, that is T dash. Antena?
Yes, sir.
So now what I can write the relation right now from this one. So this is my equation number 1 and this is my equation number 2. So divide them. So it is 2V divided by V is equals to root of 300 divided by root of your T dash. This is equation number 1 only. No? So V and V will get cancelled. No, no?
Yes, sir.
So this is total under root of 300 divided by T dash. Root this is ఇక్కడ ఎంత అవుతుంది? Root this is ఎంత అవుతుంది? 4 divided by T dash. అంతేనా?
Yes, sir.
Am I correct or I'm wrong? 2v divided by v. 2v అంటే t dash కదా. Sorry, I did a small mistake here. 2v is directly proportional root t dash కదా అన్న.
అవును సార్.
నేను 300 రాశాను మరి చెప్పు.
అచ్చా అవును.
స్టక్ అయింది.
p/300 వస్తుంది.
ఎంత వస్తుంది అన్నది? 2v divided by v అంటే this is root of t dash divided by root of 300. This way will get cancelled. So 4 is equals to t dash divided by 300. And t dash will be equal to how much? 3 4s are 12. That means this will become for me 1200 Kelvin.
Yes sir.
1200 Kelvin ante in degree centigrade ఎంత అవుతుంది అన్న? So t dash will
minus
be equal to 1200 minus of your 273. 927 degrees. That will be the answer. Okay na?
Yes sir.
927 degrees. Okay?
Yes sir.
Sure. I hope you got a rough idea related to this velocity. Okasari notes is chadunanna. I'll send you the notes also. Try to complete it .1 and try to do the PYQ. Start doing the PYQs of your sound waves also.
Okay sir.
Okay na? Ee roju sound start cheyi etti paristhitilo.
Sare sir.
Okay na? Chalo. Bye beta. నేను పంపించిన దాంట్లో సౌండ్ వేవ్ వెలాసిటీ ఆఫ్ సౌండ్ హెడ్డింగ్ ప్రాబ్లమ్స్ ఉంటే తీసి చేయి ఒకసారి 10 క్వశ్చన్స్ అయినా.
ఓకే.
చలో. బాయ్.
బాయ్ బాయ్.